Alrighty, y'all, we're going to evaluate the integral of e to the negative tx cos x from 0 to infinity, and it's going to be awesome because we're going to do a super short, awesome way to do this integral. Here we're going to use Euler's formula. Bear with me. Trust me, this is going to make our life so much easier to evaluate this integral. Okay, so cos x is the real part of e to the ix. Sine x, this part, this is the imaginary part. So we can substitute this in, and the integral becomes the real part of e to the negative tx times e to the ix, which is super cool because we can add these exponents together. This is like our friend to integrate, and it becomes the real part of e to the negative t plus ix divided by I minus tx from 0 to infinity. Now, we got to evaluate this integral and get the real part from it. So to evaluate it, in the limit as x goes to infinity, this term goes to 0 because of the negative sign right here. This is 1, cos 0 is 1, and sine of 0 is 0, so this whole thing becomes negative 1. So all of that becomes the real part of t minus I. And I have t minus I here instead of I minus t because this is a negative. This negative 1, I just distributed this negative into the denominator, and by doing that I can switch the terms, so I don't have to deal with the negative sign. To get the real part of an imaginary number, we need to put it into this form, a plus bi, where a is the real part and b is the imaginary part. Now we're dealing with a fraction, so we got to get rid of the denominator so that it's in this form. To do that, we'll multiply the top and bottom by the conjugate. And knowing, so to get this into the real form, we need to get rid of the denominator. And to do that, we're going to multiply the top and bottom by the conjugate. And knowing that I equals the square root of negative 1, so that I squared equals negative 1, if you expand and simplify this, we get t plus 1 divided by t squared plus 1. You can pause the video just to verify if you like. Now, we'll split this up into two happy fractions with the same common denominator, and voila! We now have this form right here where this first term is the real part, this is our a, and this other part's the imaginary part, but the real part is what we want. So this is the answer to our integral, 1 divided by t squared plus 1, and that's literally what it is, and we're done. Check this out. The imaginary part right here, this is the answer to if this was the sine x right here. Now, it turns out to be the same in this case, but sometimes it's not. So this is kind of like a 2-in-1 method right here. All right, y'all, if you haven't seen the integration by parts method, then you definitely need to check that out. You definitely need to know how that's done. But this is another tool in your toolkit, and all I can say is hang in there, continue doing integrals. You can survive. The more you do, the better you'll get, and I'm with you every step of the way. Cheers.